like to introduce Eric Crose from Crose Mechanical. Eric.
Talking about air exchanges, Dan, many years ago, 2017, I think, that's when Catherine Wynne had a rebate program on, and she was just starting to push heat pumps back then. So they were they weren't well known back in those days, but Ontario government, Catherine Wynne rebate program, Dan came out and, instead of 8 air changes per hour at my house, I had, 725 air exchanges. Kind of like an old farmhouse that are all, like a lot of them up the peninsula here, okay? Which goes back to the point of insulation and sealing being one of the first steps. Because, if it's all going out the window or the cracks around the window, you're not saving any money. But I did put a heat pump back at that time in my house. It was a single head one. I had a customer who wanted to buy a single head heat pump to offset their fossil fuels, and they kind of backed out at the last minute. So it was a high-end one, and I said, I'm going to walk the talk. So I'm going to throw it in at my house. And my story is I tracked it October, November, December, January, February, March, tracked all my energy costs in my house. So hydro, propane, I was heating with wood at that time, and I put the actual single head heat pump into my wood stove room. And so I tracked things. I didn't put any wood in that whole winter. It kept my house nice and warm. My propane bill at the other side of the house went down. My electric bill went up a little bit. Strange thing is Ontario Hydro kept sending me rebate checks. Like my statements kept saying negative all the time, and I didn't understand what was going on. I don't track my stuff as well as I should. And I spent no money on wood. So I added everything up, and in the first year I was $800 down on my operational costs. So if you guys have had quotes on single head heat pumps, my payback, there was a very reasonable payback time to pay back on the cost, the initial cost, installation cost of the heat pump. $800 operational cost down in the first winter putting it in. Plus, I had air conditioning and dehumidification where I'd never had that before. Okay, so there are, some good things. The off-oil program, as Dan was talking, the best thing is probably to concentrate on your insulation, trying to stop the heat loss and things like that. So, here we got a nice little thing. If anybody needs to know how a heat pump works, you can go to our website, crosemechanical.ca. We've got all kinds of information on there, and you can look at your own time. A heat pump is an air conditioner working backwards. So as I was saying in the video earlier, an air conditioner takes the heat in your house and sends it outside. So if you have an air conditioner and you go to the big box outside and you put your hand over it, it's got hot air coming out in the summertime. And a heat pump, they've got a little simple thing called a reversing valve, and all it does is it reverses the direction of the refrigerant flow. So now instead of the refrigerant absorbing heat inside your house, which boils it, so now you have a vapor, the vapor goes outside and it is expelled on the outside unit. Now it's actually the heat pump is, the refrigerant is boiling on the outside. And you're saying, how does it boil when it's freezing cold outside like today? Well, the way that works is through pressure. So as you drop the pressure of something, the boiling point drops. And with technology today, you can drop that pressure of that refrigerant significantly so that it'll boil at -20. And as it boils, it is absorbing heat from the freezing cold air. Travels through the pipes onto the inside, and now it condenses. And as it condenses, it gives up heat. And then your fan and your furnace blows by it and blows heat all over your house. Like it's an amazing technology. And how it's improved, there was a lot of people who say heat pumps don't work, and heat pumps were first kind of introduced to the Canadian market back in the 70s when electricity was heavily promoted. And there was heat pumps. A lot of houses have an electric furnace with a heat pump attachment. They're still out there right now. But the technology was such that the cost was huge. They essentially stopped working at 0 degrees, and then the electric furnace kicked in. And you know, it's amazing how people get used to $600 and $700 hydro bills if you don't know any different. Many houses I've been to, you know, the customer says, you know, I'm just kind of wondering what's going on with my heat. And I said, what's your hydro bill? Oh, I pay $600 a month in the wintertime. And I'm like, holy moly, how do you do that? Anyway, so the technology from the 70s to now is like night and day. Like back then, they didn't work very well. Nowadays, there are heat pumps, air-to-air heat pumps that will work at 100% capacity at minus 20 degrees outside. 100%. So and then as it gets colder than that, the capacity drops. The energy efficiency goes down because it's trying to pull heat out of the really cold air, and that's where your backup source of heat comes in. So, any questions on that before I move on?
I was just wondering, will this, like, say there was 20 million of these installed in Canada, would it affect the air outside? Like, you know, it's because the heat pumps creating cooler or hotter air on the outside, will it affect the atmosphere?
No, because it's not really putting anything through, so it's just changing the temperature.
Yes.
So
it wouldn't increase the temperature in the winters or decrease the temperature in the summer. So it's like, you know, because it is emanating.
Interesting thing, so when it's in heat pump mode, so when you're in heat pump mode, it's rejecting heat on the inside of the house and absorbing heat from the outside. So if you put your hand, if you have a heat pump operating outside and you put your hand downstream of the fan, it's actually colder. It's colder than the ambient air. I'm jumping around.
But that's what I mean, like, will it make winters colder?
No, I don't think so. Yeah, no, I don't think so. Yeah, good question. Yes?
I was just curious, if the government wants to do away with the flame furnace and oil furnaces and all the rest of it, you put a heat pump in, you're away with your furnace, it's minus 35, now you don't have another heat source.
Oh, you got to have a heat source, though, to set backup heat source.
If the government wants to do away with it,
So from what I understand is they want to do away with fossil fuel. So your backup source of heat, so we don't sell a heat pump without a backup source. Okay, so no matter how good it is, even though there are some municipalities that allow a heat pump system to be put in with no backup if the heat pump has a certain rating. And that's a rating down to minus 25 Celsius is what they say. So there are several of them that don't operate at 100% at minus 25, but they operate at minus 25. And there are municipalities that will allow you to put that in without a backup source of heat. I just think that's silly. Okay, so a central system, and I think Dan mentioned about the all-electric systems. So an all-electric system, heat pump's working most of the time, but it has an electric strip, like a toaster, on the inside of it that will kick up to help things out. So I think the government's trying to get away from fossil fuels like your oil and your propane, but you need a backup source of heat of something, some type of backup source of heat. You know, I get people that say, can I have a wood stove, right? Everybody's got a wood stove up here. I have a wood stove, will that qualify as the backup source of heat? Technically it will, but if you're not there, I don't recommend it, right? So that's the one beauty of a wood stove is it heats you 3 times, right? When you're stacking the wood and then when you're feeding it and when you actually burn it. Yeah, everybody's heard that one. So let's move on here. Here's just a couple of examples. There's a picture of a typical outdoor, smaller sized heat pump unit. And when I say smaller size is because you have a single fan on it. Again, what you need here is you need good airflow. You need good airflow around it. Is there anybody here who has a heat pump? Okay, so what's the big complaint in the wintertime? Not a complaint, but that's different and you don't know what's going on. It's the frost, right? So the thing has a defrost. So one of the parts of operating, as I say, it absorbs heat from the outside. So as the air blows through the unit on the outside, it takes the heat out of the air. So if you put your hand on the discharge of the fan, it's colder than the ambient temperature. And because of that, there's moisture in the air, and that moisture at certain times of year will actually freeze on it. So you're looking at it and you're saying, oh my goodness, my unit's covered in frost. And I'm panicking, and I'm calling the guy who just installed this thing, and it's like, my unit's covered in frost. Normal thing. And all it is it's freezing the moisture in the air as it travels through the coil. If you go outside and you see a gigantic ice cube, like it just came out of your freezer, that's a problem. That's when you call your guy and you say, I got an ice cube outside, and then there are, a number of reasons that could happen. We can carry on. Another, I think, if everybody looks or thinks, most people drive by that on a daily basis up here. We put that in back in probably 2017 or 2018. Carry on. So the types of heat pumps, there's a ductless and there's ducted. This is an example of a ductless. So if you have an electric baseboard and you don't want to put ducts in your house, this is a good cost-effective way of doing that. These are actually the highest efficiency at the lowest cost. There are a couple, they all look similar to that, but depending on the brand, there are some different looks to them, but they're basically like that. And the way that works is the refrigerant, the coil, the heating coil is on the inside of it, and there's a little tiny fan with a long scroll cage. And what it does is it draws the air from the room in through the top of it, conditions it, heats it, or cooling in the summertime, and blows it out through those bottom louvers. Those louvers actually go up and down. You can fix them in a certain position, but they blow air in. So the benefit of these is you don't have to have ducts. So if you have an electric baseboard house, or if you have a furnace that you don't want to mess around with, you don't want to do anything, say it's brand new, you can throw one of these in to offset your fuel costs. These work amazing on humidification as well. So a lot of people who are close to the water say, I don't really use air conditioning, and I'm one of them. So this is kind of like the one at my house. Yes?
I don't want to interrupt, but I forgot to mention in my thing, with the ductless system, with any of the systems with the grant, the wording in the grant was that the heat pump has to carry the heat load of the entire house. All right? And what does that mean? Well, if you have a central system, that's easy. It just blows air through the whole house, right? But when you have to put these ductless systems in, you have to make sure there's one head on every level of a house that's over 6 feet tall. So if you have a basement that's this tall, you've got to have one of these in your basement, even if it's just a shop. And if you have a split level house, so you got a crawl space, a basement, first floor, third floor, that house would need 5 heads, one on each level.
Yep, exactly. Yeah, so the way this goes is the air from the house travels in through the top. So ideally they were set up for air conditioning, so your heat travels to the top of the house, right? Top of the room. Gets drawn in, conditioned through the coil, and then blown out through the bottom of it. So a couple of points with that and on this, technical points, is when you have a unit like this and it's set on heat, it's actually sensing the heat at the top of that unit. Okay, so its design, its purpose is not to satisfy a thermostat over here where your normal heating system, your thermostat reads the temperature of the room. So that's what is controlling your fossil fuel or your forced air furnace, is that thermostat. These sense the temperature, the remote that you have with these, a remote control, is actually only for a set point. So you turn it to 22, it's going to continue to run until the temperature going back into the top of that unit is 22. Okay, so that's, again, that's a different thing than you're normally used to. And that's part of the learning curve that you have to do when you go through these things. The bad thing about that, the challenge of this, not necessarily a bad thing, is a lot of people have a fireplace or a heat source right close to that thing, which is giving off, the pilot is giving off heat. So now that heat is congregating at the top. It's not reading what you're feeling, like you're down here with a remote and you're freezing because your unit's not running, even though it's set to 22 degrees, and it's because it's 24 on the top of that unit, and it's only 18 over here when you're holding the remote. It's just something to keep in mind if you have one of these. My suggestion is, I say use the remote, the numbers on the remote as an indication of a level, not as a temperature. So if you're cold, turn it up. Just make the numbers go up. Don't get hung up on it. It's one of the little challenges. Continue on. Okay, here's another example. The only challenge with this one is you kind of would need a pretty tall ladder. And the reason for that is because on the inside of the front of these, you just clip them and they have like a filter screen. And it's just to clean any dust and dirt. You know, if you've got a wood stove somewhere, they kind of clog up fast, and you just vacuum them out and you put them back on. So, you know, if you've got a good step ladder, this is a good location. Other than that, you have to, you know, work around it. Also, generally, 15 feet above the floor is your maximum, because the fan and the heat won't blow down to the floor. Like, it won't blow down that far. Okay, let's carry on. Oh, another example here, above, nice one above some patio doors. This is in Owen Sound. I know where this one is. But again, it's great. So here's a major heat loss. You know, your patio doors, that's a good spot for heat to exit your house. You're trying, and this is blowing down, and it's a, you know, so it blows down towards the floor in the room. The airflow cycles back, goes back to the top, and it reads it at the top. So we talked about types of heat pumps, ductless and ducted. So these were ductless that I was looking at. So again, electric baseboard rooms, places where you don't want to put ducts in. Now, a lot of people have existing propane furnaces or oil furnaces here. So you've got your ducts there, which is really a very good way of distributing the heat. Okay, so let's use the ducts and let's pull your furnace out and throw in an all-electric system. I think we've got some pictures of some of those towards the end, Rod. I don't know if you put them on or not. Anyway, so it's a big box. So what would be replacing your furnace is an air handler. And an air handler is essentially a big box with a fan in the bottom of it and a coil, your indoor coil for your heat pump system above the fan. And so it works just like a furnace, only it uses your heat pump. As a backup, you have a little electric strip that's in the box. And the way your system works is most of the time the heat pump provides all the heat when the temperature outside is not too cold. And then as the temperature drops and the heat pump capacity starts to decline, then the electric strip kind of starts up and goes. And you're saying, well, you know, electric furnaces cost an awful lot of money. And yeah, they do. But if your heat pump is doing most of the work, your electric furnace isn't operating that often. So if you have a premium system, and this is kind of a cut and dried example, but a premium system and it's working at 100% at -20, an example, not to say that Mitsubishi is a fantastic, but it is a very good system. There's a system called a Mitsubishi Zuba, which is easy to remember, Z-U-B-A, and it's a central system. It's considered the Cadillac. It will 100% heat pump capacity at -20 outside temperatures. Then as it drops from that, that electric strip will start to come on in order to supplement. So now the cost of operation as the electric strip kicks on starts to go up a little bit, but they have them staged. So they'll have 3 or 4 or 5 coils in there, and as the capacity of the heat pump starts to drop, one coil will kick on in order to maintain the temperature in the room. And if the capacity drops farther, a second coil will kick on. So it minimizes the additional electricity as much as possible. I got one customer that we put a Mitsubishi Zuba in on Balmy Beach Road in Owen Sound, and that was probably 4 or 5 years ago, and he was telling me that he could count the number of days on 2 hands that the electric strip did most of the work. Like he said, it's just amazing. He said last winter, which wasn't very cold, he says it didn't come on at all. So it was the heat pump. The Mitsubishi Zuba did the entire winter heating season just on heat pump, and therefore very efficient costs and low costs. Like he was so sold on the thing. Any questions on ducted versus ductless? Yes. Yeah, it is. It's still a control system, and depending on the system and the setup of the thermostat, it's still trying to monitor the return air, but it has more of an ability. You can actually change it to take some of the feedback, right? Its feedback is what it is reading temperature, and you can program it to take some of it from the thermostat. Okay, so it'll take like half the signal from the thermostat location and half from the return air. And different manufacturers have different systems like that. Any other questions? Yes.
One quick one. For people that come up here on weekends, we'll say, and they've got electric heat, perhaps an alternative to that. If you put in a heat pump, which one will restore your habitat to the temperature you want, up around 75 or so Fahrenheit? How long will it take for, not sure if it will take longer for a heat pump as opposed to turning up the electric heat or taking on a new stove?
Well, okay, so you got 3 things there, but that's a great question. So a heat pumps are generally, they're lower BTUs. Okay, so when you talk about the tonnage of a heat pump, it's 1 ton is 12,000 BTUs. So if you get a 3-ton heat pump in your house, that's 36,000 BTUs. BTUs are a measurement of units of heat that it provides, on optimum conditions. Most people, your furnace is going to be 60, 80, 100,000 BTUs of heat. Okay, so there's, I go on about this for hours, so I'll try and limit it. But what you're trying to do with the heat pump is you're trying to replace the heat loss. So the heat that's going out your windows and the cracks and through the walls and stuff, your heat loss, your heat pump's trying to just replace that. The furnaces that were designed to basically bring your temperature up as fast as possible. So, there are oil furnaces out there that are, 1 US gallon is 140,000 BTUs of heat going into the thing. It'll heat your house, a standard house, pretty quickly. But you can maintain the heat loss after you've insulated everything. You can maintain that heat loss on, say, 36,000 BTUs. So you mentioned wood stove. So a wood stove, you know, after you generate the heat of chopping it and carrying it in, you know, you set the thing up, it's gonna heat up your house pretty quick because, again, not efficient, right? So it's just jamming as much BTUs. Your temperature of the smoke coming out of there is huge. So all that heat from the wood is going up the chimney. Your oil furnace, I mean, you can't put your hand on the vent of an oil furnace because that's where all the heat's going. It's going up your chimney and outside. Your propane will be a little bit better, a high efficiency propane. You can put your hand on it because it's only losing a small amount of heat, but your heat pump's not losing any heat. So technically it's like 100% efficient. It's a lower BTUs. Back to the point where you said if you're living out of town. So a lot of heat pumps, not all of them surprisingly, but a lot of them, most of them, have a Wi-Fi. So if you want to control it or monitor it, you can control it from wherever. And I mean, a lot of people, they have a Wi-Fi hookup, they've got a Wi-Fi at their house, their thermostat, and they're leaving their main house in Toronto, and they'll turn on their heat pump. And if they're careful about it, or if they set it up properly, the heat pump will gradually bring the temperature up in the house so that when they finally get up here 2.5 hours later, it's pretty much where you are. Or if you have a heat pump and there's a backup system, the backup system being either the electric or other sources, which I'll get into just in a second, will bring it up to the temperature, and then by the time you're there, it's at the temperature and it's operating on the heat pump, maintaining the temperature, replacing the heat pumps. Any other questions? Yes?
Yeah, to have a heat pump connected up to your ductwork,
Yep.
as opposed to, say, air conditioning that runs through your furnace, your fan runs to the air.
Yeah.
If you have a heat pump with a propane as a backup,
Yep. Segue.
connected up, is that still your furnace? Like the fan is still running, or does it run separate from that?
Nope, runs through the furnace. It has to have some means of distributing, blowing air past the coil. So the coil, so, yes?
I just have a question. And it's just about a different system. Like, what are your thoughts about using a heat pump for like a radiant system? Where like we want to do like indoor heating and radiators.
So water source.
water,
Yeah,
like
yeah.
heat pump to hydronic.
Yeah, no.
So is that like a usable system? You're
Yes.
talking about ductless and duct
So
system.
Rod is going to talk about his
Okay.
right shortly, and it's an air-to-water system.
Okay.
And he's the master because he has the great system at his house that he installed himself. So we'll let him talk on that one.
Okay.
Yes.
Thank you.
Can you just describe how they rate the efficiency of the heat pumps? I know the SEER rating is for air conditioning, and what's the rating for
HSPF, yeah.
So what would be a normal HSPF and what would be an excellent rating? So the ductless are higher than the air handlers?
Yeah, kinda, yeah. So I think the qualification for the greener homes, the better ones, I think was 9. I think 9 is the minimum. 10 is a pretty good one. And when you get 10, 10.5, I'm just trying to think if I've seen an 11 for a centrally ducted unit or not.
I've seen 12 for ductless.
For ductless, yeah, ductless is way up there, okay? So I think there are some losses with the ducted system with that, but I mean pennies, like pennies type on thing. So when you're looking, so that, you know, a great point, there is the SEER. Some people may have heard of SEER. SEER is only for air conditioning. Okay, so your basic air conditioner, normal air conditioner, not side discharge like these are that we're talking with the heat pump. Your normal SEER for an air conditioner, the lowest you can do is 13.2 now. Last year it was 13 SEER. 10 years ago it was 10 SEER. I mean, the energy of the minimum efficiency is climbing. These heat pumps, these ductless systems that we're doing here, I mean, they're kind of starting at 19 SEER. Like, on air conditioner, it's amazing. That's why I just kept getting these rebate checks from Ontario Hydro after I put one at my house, because they weren't using any energy hardly at all. Like, they're so good on dehumidification and air conditioning. I can't even tell you how good they are. If you have an air conditioner in your house, these things here your energy will just drop like a stone. Any other quick questions before we move on? Yes.
Will the small unit you mentioned work in a stone crawl space that's spray foamed, and how much height do you need to put it down there if it does work?
The outdoor or the indoor unit you're talking?
Indoor.
So you're talking central ducted?
Yeah.
Well,
You don't have room and there's no basement, would it look, all kinds of.
well, so mostly you can put them horizontally. That's another beauty with the centrally ducted air handlers, is almost all of them that I can think of are multi-positional. So when you have a small crawl space and you get a couple of small installers that can go down there and install them, you can actually put them on their side and duct it that way. So pretty much it's ideally, just to be nice to the people who have to work down there, 4 feet's good. I talked to one of our duct guys that does the duct work, and I asked him if a 3-foot crawl space, if he would do duct work in a 3-foot crawl space.
I did one yesterday.
And he said yes.
Crawl space, and they had a furnace jammed in there.
Yeah.
I don't know. I was supposed to go over and get a picture of the plate, and I said, no, I'm not going in there. Like, seriously, it was just big enough to turn sideways, and somehow they got a furnace down there.
How big is
And they jammed it in.
the unit?
Pardon me?
How big is the small unit you were talking about?
A ducted one? Well, sideways or vertically? So vertically, they're quite tall, okay? So if you have a basement that you want to put it in, and you don't want it for whatever reason, you don't want to redo your duct system in order to have it horizontal, because there's quite a bit of work with that, you need ample room to run these air handlers vertically. There's some different sizes, but I mean, if your basement is smaller than, say, here, you're gonna need to do it horizontally. So just kind of keep that in mind. Now, having said that, again, depending on what fuel source that furnace is, you can put a ductless system upstairs to look after all that. Put a small one, if you're going for a grant or a rebate, put a small one somewhere over, by the stairs or something in the basement to meet the qualifications, like just a small 6,000 BTU unit, And then the other ones, you can put ductless system in there, and that'll save on your furnace. So an example is, I was saying this story earlier, my girlfriend sold her house. We bought a house together out in the East Coast 4 or 5 years ago. It's got an oil furnace, like a ducted oil furnace. And, the shoemaker's children, again, my goal eventually is to replace that with a heat pump, or we sell the house. Anyway, so what I did is just before last winter, I put in a single head, same as at my house, single head ductless system up in the kitchen on the main floor, and I put a Wi-Fi thermostat to control the oil furnace in the basement. Okay, so I can monitor the temperature of the basement where all the water is. I can turn the oil furnace on or off. We've got the ductless unit upstairs blowing heat in the thing, and we can monitor the temperature. And my girlfriend comes up and she says, "Oh, I can't believe I got a $350 hydro bill for 2 months out there. I've never had that before." And I said, "Well, what's the oil bill?" "Well, I don't know. You do that all the time." And it's like, well, okay. Last winter we went through a tank and a half of oil, and we weren't even there. And this year, the past winter, not this one, but the past winter here, we used a quarter tank of oil. Quarter tank of oil, hydro bill did go up, but I mean, the savings was unbelievable over oil to maintain with this thing. And now we've got air conditioning and dehumidification and the whole bit, right? And then the Wi-Fi, you can watch it and control it from in the past. And anyway, it works really good. Any other quick questions here? Oh, holy mackerel, they're coming over. Yes.
So I have a electric forced-air furnace. So my question is the ductwork. It's a two-story house. And my question is, can one augment the current furnace, you know, 20 years old, with a heat pump? Or given that electric furnaces are probably more efficient, that we just sort of replace the whole thing with like a Zumba instead? Which is the better way? Well, I don't even know if you can just augment a current electric furnace.
Oh, yes, you
You
can.
have to replace the whole thing.
You can. So that, okay, that's another segue. So they also have heat pumps that will add on to your existing furnace. So think of an air conditioner that you're going to throw in a coil above the furnace and you got your outside unit. They have heat pumps that do that. They did qualify for the grant during the grant thing. There's question whether they are qualifying for the off-oil grant or not, but you can hook an additional one up there. Depending on the level of heat pump that you use, again, not only with the old, how old is the electric furnace?
Oh, it's coming on 20 years old.
Okay, so another little increase that started back in the early 2000s is they switched the electric blower motors. They've now made it so all electric blower motors for forced air heating equipment are ECM motors. Again, without getting too technical, an ECM motor uses about 30% of the power of a normal, your oil furnace blower motor. Your old motors used to be split phase motors, and then they were permanent split capacitor motors, and now they're ECM motors, 30% of the power. And that's been verified by a customer who tracks it. So just the blower motor on that electric furnace, by replacing that whole thing, you are miles ahead, like miles ahead. Any other quick questions? Yes?
The units like that, does it need special wiring on to put by an electrician?
Lots of points to that one. Okay, so this one here, the electrician needs to provide like a 240 or a 208, 230 to the outdoor unit. And then there's a communication wire, which provides all the, you know, this will tell the outdoor unit through that communication wire how it's supposed to do. It'll ramp it up, ramp it down, shut it off, whatever, depending on the temperature. Most of the manufacturers, 2 out of the 3 wires in the communication cable are 120 volts. Most electrical inspection agencies will allow properly certified guys like us to put those in without an inspection. Some of them have 24 volt cables and then you don't need anything. There are systems that they're called variable refrigeration volume, or VRF, variable refrigeration flow systems. They're completely different systems, very high end, very good, and they require an electrician to run individual power to each inside head. So it kind of depended on what it is. But most of them know, to make a long story longer. Yes?
Nobody's talked about what that costs. Like their basic unit, or a small unit like that, what's...
Well, there's a big wide range. Depends on the number of heads, size of the house, the number of floors that you're going to insulate, number of rooms.
Or if you go at the cubic feet of the house.
So the number of heads, how much distribution you want, do you have a wide open space, do you want individual bedrooms? Each individual head puts an added cost, to like a substantial added cost.
Say a single head, 1 unit, a single head.
The range, again, based on performance and manufacture and all that stuff, you could probably get one installed as low as $4,000. Okay, you get a good one, like a really good, like high quality, really low outdoor temperature, very, very high efficiency, might be $8,000 for a single head. Okay, so, yeah.
That's the ballpark.
Yeah, that's a ballpark, and then as you add heads, the price starts jumping pretty good. I mean, these ductless systems, you can actually get systems that have like up to 9 indoor heads. It's quite a price, but we've put in ones that have 7 indoor heads, that the people want. They don't want ducts. They're really, concerned about their look and stuff, and they want to use these things. And yeah, it takes quite a while to put a system like that in, but they work awesome, and it's probably, well, I can't say it's paid itself off quite yet, but I don't know what their energy bills are. Yes?
Eric, will each of the ducts take its own thermostat?
The ductless?
Yeah.
Yes, good point. So each of these indoor heads has its own control. So if you have 3 indoor heads, so here's a perfect example. Somebody's gone for the rebate, they've got a second floor, they've got a main floor, and they've got a basement, okay? So each of those floors has different heating and cooling requirements at different times of the year. Okay, so in the summertime, your main floor may not need any cooling, may not need anything. So you can leave that remote and that head off. But your second floor is like sweltering most of the time, so it's on air conditioning. And now your basement, you've got it switched to dehumidification. Okay, so all it's doing is taking the humidity out of the basement. The second floor has got all the cooling. The cold air is kind of wafting down the stairs, and your main floor doesn't have anything. Now it's the winter time. So again, you may have your basement on low because nobody lives down there. So just to keep the chill off of the basement. Your main floor is set at 22 degrees. And you know what? All the heat kind of goes upstairs anyway, because that's the way our house is. So we're going to leave that third floor off. One of the benefits is you have individual control over each of the indoor heads on a multi-head ductless system. A lot of people really find that good. Yes?
What would the average price for a ducted system for, say, a 3,000 square foot bungalow?
3 foot,
300 square feet, yeah.
3,000 square foot?
Yeah, that's taking basement as well, so it'd be 1,500 being the main floor.
Oh, okay. Average, okay, so again, depends on the level of the system, how good it operates, the manufacturers, yada, yada. So does it qualify? There are qualifying systems, there are non-qualifying systems. I'm gonna say maybe 12, 13, 14. Now a Zuba, going to a Zuba is a very high end, it's a very good Cadillac of it, it might be 20 grand. So, yes? No, you're using the existing ducts. Yeah, a duct system, again, depending on the house, duct systems to install is 95% labor because it takes so long to put them together, and the material's pretty cheap, but I mean, yeah, you could be 8-10 grand on a 1,500 square foot house. Bungalow doing ducts, you could be 5 grand, you could be 10 grand, it depends. Yes?
I'm just trying to understand how the terminology of heat pump changed. Because my understanding back in the day of the heat pump is that the heat and the cooling were coming from the ground. And you actually had things going into the ground, and that was what you were using naturally available heat and cooling. Now, are we using electricity to replicate this natural available heat and cooling?
No. So, okay, so you talked about a couple of different types of ground source. I'm running out of time.
Maybe 2 more questions or something?
Oh, okay, so back to this thing. So you were talking from the ground as a ground source heat pump?
Yeah.
It still requires electricity to get that heat from the ground up into your house.
But nothing that you've spoken about here has talked about anything like that.
Ground source, no.
No. So is that something that's still available, or that's not?
Yeah. Ground source is available, still uses electricity.
And then we're still offering a $5,000 grant to install a heat pump, and a $3,000 grant to replace. Like if you already had a heat pump that the guts died, they're giving you $3,000 to replace the heat pump part of it.
Okay,
But it's still an option.
Yeah, sorry, but it didn't sound like it even existed anymore.
Yeah, no.
No, it's just we're focusing on air sources today, so.
Yeah, so a ground source, so an air source heat pump's taking the heat from the air. Okay, ground source is taking it from the ground.
Right.
Okay, so the relative costs Again, I'm not saying it's bad, but the relative cost as a ground source is a whole lot more money than an air source ever will be. Because you actually, the installation is, backhoe, dig big holes into the ground and stuff like that. So that's not, we don't do that. We can repair them. But that is another source, works exactly the same way. Instead of taking the heat that's in the air at -20, it's taking the heat from the ground.
Which is definitely not -20.
Which is definitely not -20. Nope, it's just like I said, a ground source heat pump is the same thing, only different. Installation is different, and cost is quite a bit different.
Yeah, but that unit that's taking the air outside at -20 is working a lot harder to turn that -20 into something that you can use in your house as opposed to the ground. So I'm just trying to understand the wear and tear on the newer units to replicate what was done before. Am I being clear?
Kinda. So if you're interested in that, Google it.
What drove the change? Just economics. It's cheaper to put something outside of your house than to dig down to access what's in the ground. Is that what we're thinking?
Say that again?
It's easier to just put a unit outside and have it draw the air from outside of there. The temperature is there, than digging down into the ground to access. It's got to be cheaper to just have it outside of the house
Yes.
than it is to go down.
Yes.
Yeah.
Yeah, absolutely.
And that's what's driving the change to this model.
Yeah, it's not, the ground source is still available. There are lots of people that swear by it, but it is a higher initial investment considered.
So how do you feel about the longevity, one to the other?
My personal opinion?
Yeah.
So my personal opinion is based on my experience. I never go by what other people say. So when people ask me about heat pumps, how long they're going to last, I say, well, technically I haven't been around. We haven't been installing these air source heat pumps long enough to give you an honest answer. Okay? So the ground source has been around a long time, and we've replaced a lot of ground source with air source heat pumps. And when they were installed 20 years ago, it was $25,000 to put that ground source in, and 15 years later, we're replacing it with an air source heat pump. Okay, I'm not saying that that's all of them. I'm just saying that that's, the highlights of my experience. Okay, we've repaired quite a few of them. A lot of people swear by them. The ones that they're still working, they love them to death, and they love them, and they will love them until they have to replace them or they have to repair them.
Well, what you would clearly now is the ground source would not be the same technology until the 25 years.
No, not 25 years ago, but surprisingly, a lot of the technology is pretty good. They were pretty advanced back then. Yeah, the refrigerant's different. Some of the things are different, but the essential thing is the same.